Hello everyone, welcome back. In the previous section, we have seen about IP address. It is the address or the name given to the device so that it can be identified over the network. In this session, we are going to discuss about IPv4 and IPv6 and their differences and how are they notified. Coming to IPv4, IPv4 stands for Internet Protocol version 4. IPv4 is of 32-bit length. A bit is nothing but either a 0 or a 1. It is very difficult to remember 32 bits. So we have divided 32 bits into 4 octets. Octa means 8. That is, every octet has 8 bits in it. The 32-bit IP address is divided into 3 parts, namely priority, network, and host portions. An example for an IP address with IPv4 can be 127.255.54.10. Let's see the ranges of IP addresses. The IP address starts from 32 zeros, incremented by 1, and reaches 32 ones. As a human beings, it is very much difficult for us to manipulate or remember these bits. Each bit, again I repeat, each bit is nothing but either a 0 or a 1. As there are total of 32 bits, so 2 power 32 combinations are possible for IPv4 addresses, which is approximately equal to 4 billion. So, as I mentioned earlier, remembering 32 bits is very difficult. We have divided them into sets of 8 bits and each set is known as octet. This makes easier to represent the numbers as shown here. It is always difficult to remember these binary numbers, so we convert them into decimal formats. So every octet is represented with its decimal equivalent number. For example, if there are 8 zeros, it is represented as decimal 0. And there is one more example given here, that is 4 ones 0101 can be represented as 245. If all bits in the set or octet are ones, then it is represented as 255. A 32-bit IP address or 4-octet IP address is contains priority bits, network bits, and host bits. The most significant bit, that is the bit that is present to our left hand side in the address, is called as priority bit. Priority bits helps us in classification of the IP addresses. Based on the priority bit, we determine the class of the IP address. Network bits. Priority bits followed by network portion are considered as network bits. These bits are helpful to identify the network. The network bits will be same throughout the network. If any bit in the network portion is changed from 0 to 1 or 1 to 0, then its network is changed. Host bits. The least significant bits in the address after priority and network bits is referred as host bits. The host bits are the ID of the machine in that particular network. So IP address is nothing but priority bits plus network bits and your host bits. This is in brief about IPv4. Let's move on to IPv6. As discussed earlier, IPv4 is of 32-bit length. It can generate up to 4 billion IP addresses. With the amount of devices that are connected to the network increased, the IPv4 soon become exhausted because all the IP addresses available in the IPv4 pool are assigned to the devices. If a new device wants to enter into the internet, there is a shortage of IP address. As there is no IP address to the device cannot communicate with the internet. To overcome this issue, IPv6 is designed with 128 bits, that is 2 power 128 combinations are possible. So 2 power 128, which is a huge number, approximately around 340 trillions, I guess. Remembering 32 bits is more difficult than imagine about a scenario when you have to remember about 128 bits. It's a big challenge that we can't remember those words. As it is very difficult to remember 128 bits, we convert them and represent them using hexadecimals. Each digit in a hexadecimal will be equivalent to 4 bits. That is, 2 octets will be considered as a set in IPv6. If you can see here, FE80 is one set, it can be represented in 16 bits. Similarly, this is the case with all other sets. For example, consider FE80. It is equivalent to 16 bits, that is 2 octets. Each and every set present there is equivalent to 2 octets. IPv4 was exhausted on February 3rd, 2011, as all the IP addresses are assigned to the devices that are present all over the world. It is when IPv6 made its debut. Even though IPv6 made its debut in the year 2011, still there are many devices that are running using IPv4. Hence, the knowledge on IPv4 and IPv6 is more needed. In the next session, we will be discussing about the classifications of IP addresses. Thank you.